Audible, right? Okay. First, in civil engineering, we have a main 5 branches. First one is a structural engineering, second one geotechnical, third one water resource engineering, and the fourth one transportation engineering, and environmental engineering. Okay, out of these, now we are here, that is a water resource engineering. In this water resource engineering, we have fluid mechanics, open channel flow. Fluid mechanics means here only I will explain that HHM part, that is applied hydraulics part, and open channel flow is a one separate subject we are going to consider. And after that we have irrigation and hydrology. We make our first hydrology and later irrigation, and after that we will go for some other subjects like groundwater flow, groundwater and all, that we will see later. Now we need to cover these, and after that we will enter into environmental, then for transportation, right? This is our flow. Now we are concentrating on only fluid mechanics, concentrating on only fluid mechanics. In this fluid mechanics, what all chapters will come, that we will see. In this fluid mechanics, for gate purpose, the properties basic chapter is this: properties of fluid, properties of fluid. And the second chapter we will study measurement of pressure measurement, we can call pressure measurement. Simultaneously make a notes. Okay, don't make only that what observing or watching the video, it's not enough. Simultaneously you just make one rough notes, and later you can make it original notes, for your reference. This pressure measurements we are going to study, and here we are going to study static pressure, static fluid. Okay, and after that we will study buoyancy and metacentric, buoyancy and metacentric. Then after that we will jump to kinematics, fluid kinematics, fluid kinematics. And then we will study about Bernoulli's equation, that energy principles, energy and other things, energy and momentum application, that all comes here. Then we will go for laminar flow, laminar flow. Laminar flow means that pipe flow we will consider. Then laminar flow, then pipe flow, pipe flow. Then after that turbulent flow, turbulent flow. Then boundary theory, boundary layer theory we call, boundary layer theory, boundary layer theory. These many things we need to study. And after that open channel flow, we will make a separate chapter for that one, separate module. Now in this fluid mechanics we need to study all of them. Do you have anything to ask here? Is there any doubts? No doubt. Now we will go one by one. The timing, how many days it may take. Fluid properties may take 2 days. Fluid pressure and static pressure, 1 day or 2 days it may take. That question and answer including. Buoyancy, 1 day is enough. Kinematics, from here I will collectively I will put all of them for 5 days or 6 days. Totally 6 days and 7, 8, 9, 10, 11. Okay, total about 15 days we are going to complete fluid mechanics. Within 15 days we will cover fluid mechanics. And fluid mechanics here, and one more thing, those who are studying this gate examination just for qualification purpose, for them there is a note. Okay, just qualification or otherwise some other competitive exams and all, For them I will give one note like if you are preparing a selected subject, if you are preparing like a selected subjects like geotechnical, environmental, transportation, structural, in that SOM, like that, if you have a selected subject in your list, if fluid mechanics is not there in your list, if fluid mechanics is not there, then also you need to study fluid mechanics as a few chapters like fluid properties and some basics of Bernoulli's equation, basics of turbulent flow, basics of laminar flow, like that, a little basics you need to know about. Now then I can say that you did not touch the fluid mechanics. And in your list, if this fluid mechanics is there, means in your list, if you are already made that fluid mechanics in it, then you need to study thoroughly. You should not skip anything. Okay. Now those who don't have this fluid mechanics in your list, then if you study basics, you may cover about 1 or 2 marks. Easy questions you can touch and get the marks. And if you this fluid mechanics is there in your list, then it will come about 6 marks in gate examination, and all 6 marks you can get, and the most probably the problems will be there. That's why study seriously this fluid mechanics. And if you are not getting any some mathematical equations, mathematical functions, then you can skip those chapters if you wish. Okay, I don't suggest, but if you wish you can skip. Now we'll go to the first chapter, properties of fluids. Properties of fluids. Okay, first we should understand what is a fluid and what is mechanics. What is this fluid? Fluid word is made up of flow. Flow is there, no? Flu also, flu or flow means what? Which is continuously flowing. Which is continuously flowing is called as a fluid or flow. Which is that which is continuously flowing? What is that? The continuously flowing, we have two objects in our nature. The one is a liquids. Liquids are continuously flowable, and gases. These two are continuously flowable, means they don't flow by themselves. For a small application of forces, they continuously be in the motion, then they are called as liquids or gases. Together we will call it as a fluid. You should know that fluid means it is the liquid and gases, or gases and r. Okay, and r. Liquid and gases, liquid only, gas only. Okay, like that. Most of the time civil engineering students deal with liquids, because we are not students of aerodynamics, aeronautical engineering is there, no aeronautical engineering, we are not from there, that background. Therefore most of the times our fluid means it is a liquid. And later after this fluid mechanics, when you jump to open channel flow, irrigation, hydraulics, hydrology, and there most probably fluid means liquid, liquid means water. Okay, but now don't make any conclusion that fluid means liquid and gases. Particularly we study about liquids. Okay, liquids of all specific gravities, different types are there, that we will discuss. Okay, now then you got the meaning of fluid. Next the meaning is, what is mechanics? What do you mean by mechanics? Mechanics means what? This word always many times we that what it comes in civil engineering. We have engineering mechanics, solid mechanics, that is your strength of material, solid mechanics or mechanics of material, fluid mechanics, soil mechanics, rock mechanics, like that. Mechanics word is there. Mechanics means what? The force and their responses. Force means not this arrow force. Force, it might be that whatever linear force, or it might be moment is also force. Okay, and it might be torque, or it might be anything, bent, whatever that is. Force means what? Just you are one external agent which is changing the state of motion, that is a force. Then responses means what? Responses, it may be deformation or elongation, contraction, twist or bending, slope, deflection. See, these are all what? Displacement, deformation, deviation, deflection. These are all what? Responses. And this is the force and this is the responses. Now, on which body you are applying the force? On which body's response you are going to study? That defines your mechanics. Here we are defining, we have a fluid mechanics, means what? On a fluid we are going to apply some force and we are going to study the response. Apply some force on the fluid and study the response, that is called as fluid mechanics. Any doubts here? Till here, if you have any doubts, you can ask. Okay. For study purpose, this fluid, when it is flowing, I told you, no, it will be always flowing. If I consider this is one surface and this is a water surface, and if it is, this fluid is moving, it might be air or liquid, fluid is moving, then we will assume one thing, that it is moving in a layer wise layer. It has some layers inside it, and through the layers it is going to move, and there will be some friction between the two layers, and that also we will study, and the friction between the top layer and the air above, and the friction between the bottommost layer and the surface. Like that, there are many types of frictions we will see when it is moving. That friction you can call it as, sometimes we will call it as a shear stress inside the fluid, or sometimes we will call it as a viscosity. When we will call viscosity, when we will call shear stress, we'll see later. We will call viscosity. Viscosity means also resistance offered by the two layers. Shear strength is also the stress induced in between the two layers when they are moving. That is your shear stress or viscosity. Okay. Now, when the fluid is in the rest, see, this is a water tank, and here the fluid is at rest. When the fluid is at rest, then we will not make this assumption. We will not make this assumption. Which assumption? The fluid is in layers, in many number of layers. No, this is wrong assumption, because it is not moving. When we are not making this layer assumptions, then in static fluid we will not see any viscosity, we will not see any shear stress. Understood now? Because we don't have any motion. When there is no motion, then there is no resistance. Therefore, we don't have any viscosity or otherwise shear strength when the fluid is at rest. This is very ultimate question they may ask, or an ultimate concept we should remember. Right? Next, we will make another assumptions before going into the fluid mechanics. The fluid is homogeneous, homogeneous, and the fluid is continuous, continuous. Okay. First, what is this homogeneous means? What homogeneous means? You have, if this is a water tank or some other fluid tank, here there is a fluid here, and this fluid you are going to study here, and this fluid everywhere has the same property, everywhere has a same property. Let us consider this point. What is the density? Yes, it is one density, 1000 kg per meter cube. Here 1000 kg, here 1000 kg, 1000 kg, 1000. Everywhere, wherever you go, wherever you find a point inside the fluid, then you will be having the same property. Property means not only density. What all properties are there? Density is a property. Unit weight is a property. Your specific volume is a property. Specific gravity is a property. G we will use. Specific gravity is a property. Surface tension is there. Viscosity is there. Compressibility is there. These are all properties of fluid. Okay. Then what is this homogeneous means? Homogeneous means everywhere inside the fluid, these properties are same, constant. Okay. Okay. Now look at here. You are living in one room, right? Okay. All of you are in a one particular room. Let us consider this is a room. Okay, this is your home and windows, and you enter inside, and here there might be one table, and on that table you are sitting here and studying, right? Here you are studying. Now inside the room, what is there? Air is there, no? Air is there. Now, here one window is there, therefore the that what velocity is more here, the density may be less. Here there is a cold environment is there in this corner, therefore you may have a high dense air here. And here some kitchen is going on, therefore the temperature is increased, the density is decreased here. And here something like that. Now see, in this entire body, the property of the air means what? Fluid. The property of the air is not constant, then whatever I am studying in fluid mechanics, that won't work here. Therefore, first only I made an assumption, that is the homogeneous, means whenever I consider a fluid, then everywhere you should have a same properties of the fluid. Then I can say the fluid is homogeneous. Okay, then you pursue your study. The second one is continuous. Second one is continuous. Most of the times all liquids are continuous. What is the meaning of continuous? I am going to tell you. Means, let us consider this is one pipe here, this is one pipe here, the water is coming like this and water is moving like this. Okay, and at a particular section, let us consider at this section the water is disappeared. Is it possible? Disappeared. Is it possible? No, because it is moving. No, the water is moving, means there must be a water. Huh? There shall not be any voids here, or some air bubble is there, but still a fluid motion is there. No, this is a foolishness. No, therefore always we consider that the fluid is continuous. Continuous means the flow is continuous. Okay, it is not stopped. If it is moving, it is continuous. Then the word homogeneous plus continuous, these two we will club together and we will call it as a continuum. continuum, continuum we will call it. You should know what is the continuum means. What the flow is, the fluid is homogeneous and continuous. Homogeneous and continuous. Here we will not we will not use the word isotropic, no, because we don't know in all direction whether the property is same or not, that we don't know. Therefore we will not make this assumption. We want homogeneous and continuous, and if both are satisfied, then we will call fluid continuum. Fluid continuum. Right? Do you have any doubts? Okay, next we will study what is the meaning of pressure. What is the meaning of pressure? Okay. Pressure means we have a two words which are confusing. The first one is a pressure, and the second one is a stress. Okay. For time being, you just remember that the stress is the word we will use it for solids, and pressure is the word we will use it for liquids or gases or fluids. Okay, pressure word will be used. Then what is exactly this stress and pressure is? Stress is always a concentrated, and in a one particular direction it will be flowing, that is the stress. And pressure is the average of stresses, I can call. Say for example, here we have a varied pressure, like that we have a varied pressure here on this surface. Then this one I will call it as a average pressure, or otherwise simply a pressure. Then the stress is what? Always for the solid bodies. Now the definition is same. What is that? Force divided by area is your, you can call it as a pressure, or you can call it as a stress. Force divided by area. Then what might be the unit? Newton per meter square you can call, Newton per mm square you can call, kg per meter. Whichever you feel comfortable, that unit you can consider. But usually we should know the unit conversions, that is your Newton per meter square is considered as a standard, and this is called as a Pascal. Okay, then 1 Newton per meter square is considered as 1 PA, 1 Pascal. Then 1 Newton per mm square, we will consider it as 1 MPa, 1 mega Pascal. Okay, then like that you can make any other notations, like even sometimes fluid can be measured in Newton per centimeter square. We will use a two conventions, that is Newton per meter square we will use, or sometimes we will use Newton per centimeter square. Sometimes we will use KPA. KPA means what? 10 to the power of 3 Newton per meter square. This is your KPA. Okay, this MPa we will not use this one. MPa is preferred for solids. Okay, therefore Newton per meter square or Newton per centimeter square we will use in fluid mechanics. Right?
Sir,
Huh.
sir, fluid exact definition in sir.
Fluid andra the which flows continuously with a small amount of force. Fluid is a substance.
Particles,
Hmm?
sir, size of particles are same.
Almost molecules we will call in fluid mechanics. We will not call size of the particles. We will call molecules. The size of the molecules are somewhat same, uniform size. Okay. The fluidic definition you write it like this: fluid is a substance which is which tends to move in a continuous with a small application of force. Substance which deforms continuously when subjected to a small amount of force. Right?
Sir,
Sir, ಇನ್ನೊಂದು ಸರಿ ಹೇಳಿ ಸರ್ ಅದು.
Evening barcode. Fluid is a substance which deforms continuously. Fluid is a substance which deforms continuously when subjected to small amount of force. ನೋಟ್ಸ್ ಬರ್ಸ್ಲೇನೆ ಎಲ್ಲರಿಗೆ ಏನು ಹೇಳ್ಕೊಂತ ಹೋಗ್ಲು?
ಬರ್ಸಿದ್ರೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಸರ್.
ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಹಂಗಾದ್ರೆ ಫಸ್ಟ್ ಹೆಡಿಂಗ್ ಫ್ಲೂಯಿಡ್ ಬರ್ಕೊಂಡ್ರಿ ಈಗ. ಆಫ್ಟರ್ ದ್ಯಾಟ್ ಯು ಡೈರೆಕ್ಟ್ಲಿ ಜಂಪ್ ಟು ಕಾಂಟಿನಮ್. You can write that equation also. Continuum is an assumption made in fluid mechanics. Assumption made in fluid mechanics says ಅಥವಾ ಡೆಪಿಕ್ಟ್ಸ್ ಅನ್ಬೋದು ನೀವು ಚೆಂದಾಗಿ. ಡೆಪಿಕ್ಟ್ಸ್ ಕಂಟಿನ್ಯೂಯಸ್ ಆ್ಯಂಡ್ ಹೋಮೋಜಿನಿಯಸ್. Continuous and homogeneous. Next, very important, note. ಬರ್ಸ್ಬಿಡ್ತೀನಿ ತಗೊಳ್ರಿ, ಅಂದ್ರೆ ಯಾವ ಮರೆಯಂಗಿಲ್ಲ. ನೋಟ್, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಟ್. Liquids are always continuous. Compressed gases continuous. Or continuous. Then low dense gases not continuous. Vacuum flow ಅಥವಾ flow in vacuum is not continuous. I will explain you the meaning of vacuum. We don't know what is the meaning of vacuum. That I will explain you later. Now put the heading pressure. Pressure you put, and pressure means you already know. Pressure is the average stress. Average stress is called pressure. You can write at some point. Average stress. And formula you can make it like a P is equal to force by area. Force by area. Then unit. 1 PA is equal to 1 Newton per meter square. 1 MPa is equal to 10 raised to 6 Newton per meter square is equal to Newton per mm square also. 1 kPa 10 raised to 3 Newton per meter square. 1 GPa 10 raised to 9 Newton per meter square. Or also we can use it like 1 Newton per centimeter square also. We will use it. Then put a star here for 1 PA, 1 kPa and Newton per centimeter square for these. These are oftenly used.
ಸರ್ ಇದು ಸ್ಟ್ರೋಕ್ ಒಂದು ಯೂಸ್ ಮಾಡ್ತಿದ್ರಲ್ಲ ಸರ್?
Stroke ಇಲ್ಲಿ ಬರಲ್ಲ, ವಿಸ್ಕಾಸಿಟಿ ಒಳಗೆ ಈಗ ಇಲ್ಲಿ ಬರಲ್ಲ. Stroke is the unit used in viscosity, not here. CGS units ಅಂತ ಬರ್ತದೆ. CGS units if you are using, then you can get kgf divided by centimeter square. But not kgf.
ಸರ್ ಸರ್ ಏರ್ ನ ಗ್ಯಾಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರ?
ಹೌದು, ಏರ್ ಇಸ್ ಅ ಗ್ಯಾಸ್. ಓಕೆ,
ಯಾವ ಗ್ಯಾಸ್ ನ ಫ್ಲೂಯಿಡ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ ಸರ್?
ಆಲ್ ಏರ್ಸ್ except solids, everything is fluid. Okay, except solids. Water, gasoline, kerosene, petrol, diesel, oil, and air, nitrogen, oxygen, vapor, even water vapor is also gas. Or LPG. LPG liquid ಒಳಗೂ ಬರ್ತದ, ಗ್ಯಾಸ್ ಒಳಗೂ ಬರ್ತದ. Liquid petroleum gas. Like that. Acids, you can consider some acids, liquid, acetylene. Few acids are in gaseous form, few acids are in liquid form.
ಸರ್ ಏನಾದ್ರು ಡಿಫರೆನ್ಸ್ ಇದೆ ಸರ್? ಎರಡು ಸೇಮ್ ಸರ್ ಗ್ಯಾಸ್ಗೆ ಏರ್ಗೆ?
Properties will differ. For example, when I study viscosity, then I will study viscosity different for liquids, and viscosity I will study different for gases. Hanga properties. Surface tension, when I am studying, then surface tension study for liquids is different, and for this is also different. Gases are different. Then the difference between these two is the particles are very far away from each other. Elli gases olagade. This is gas. We studied even in 3rd standard also. And in liquids what happens? They are somewhat closer to each other. Okay, this is your liquid. That's why the continuous means what here? The continuous means we don't observe any gap between the particles. That is called as the liquids. See, that's why I told you the fluid, that what liquids are always continuous, but gases are not continuous. Compressed gas is continuous. See, this is the example of liquids. This is example of gas. ತಿಳಿತು?
ಎಸ್ ಸರ್.
Okay. And most of the things in the atmosphere is a gas, that's why the fluid mechanics is a very, very important subject. Wherever you go, there is a pressure, there is a liquid, there is a gas, everywhere in our total entire body is running under with the fluid mechanics concepts only. Your blood pressure, eating, swallowing, drinking, breathing, blood pressure, heartbeat, everything is the fluid mechanics inside the body. Okay. Now we will write some more units for pressure. We will write this 1 atm, 1 atmospheric pressure is equal to Newton per, 101,325 Pascal. 1 atmospheric pressure is equal to. This pressure distribution I will tell in details in the next chapter. Just write it here, 1 atmosphere equal to this much, or you can write it like 101.325 kPa. We will have 1 bar. 1 bar means 10 to the power of 5 Pa. This is 1 bar. Okay. Then we have 1 tor. 1 tor. 1 tor is like 133.416 Pa. Not that is useful this tar, but still you should remember. Okay. Then some other conventions are there like 1 mm of Hg, 1 meter of Hg, 2 meter pressure, 5 meter pressure. These all things I will explain in the next chapter when I study complete detailed about pressure. There I will study that one. Okay, na? Now you already got one information that I already told. Actually, it has a different heading. You can write here different types of substance. You can write types of substance. Types of substance. You already know the first substance is what? Solid. Second one is a liquid. The third one is a gas. Fourth one is vapor. Vapor we will consider it as a one substance. But atmosphere, if you cross atmosphere, we have one more substance, ether. That we will not study. Okay. Now put the heading properties. Properties. Now we are entering into a properties. One more thing. Here, a pressure. Do you know what is temperature? Basic. You should be very clear about them. What is the temperature? Temperature is a one unit, one measuring unit. It is a fundamental unit. To measure what? To measure the friction between the particles. Say for example, this is one particle, and this is another particle. Between these two there is no vibration. This body is not vibrating, and this is not vibrating. Therefore, we call this one as a cold body. Cold body andre there is no vibration. Cold body, or we can call it as a static. See, the word first I used the cold, later I am using static. Static means what? They are not vibrating. Then what is the temperature here? Temperature is 0. Huh? Temptation under that temperature is 0 here. Why? Because cold body or static body. Then this body starts vibrating. Then this is also vibrating, and in between these two some heat will be generated. When they vibrate very fast, then there will be some liberation of heat, and that heat you are going to study in a degree centigrade. That heat you are going to study, that is a degree centigrade. Understood? Now let us consider, I have one particular gas here. This is a cold gas. Cold gas means what? All particles are just staying at their positions. Now because of some external agent, the temperature is increased. We call it as temperature is increased. Actually temperature is not increased. The particles are vibrated. When they start vibrating, then they make a friction. They rub each other. Then some temperature will come. Some heat will come. That is measured. That is called as temperature. See, when you increase the heat, the particles will move away from each other or come closer to each other. Tell me. When you heat, particles will move away from each other or come closer to each other.
Away, sir.
Very good. They move away from each other. Okay. Means now tell me the relation between pressure and temperature. As the temperature
Inverse.
increases, pressure increases at that point or decreases? Let us consider closed environment. Hmm. ಏನೋ ಒಟ್ಟಿಗೆ ಏನು ತಿಂತೀರಾ? ಒಟ್ಟಿಗೆ ಏನು ತಿಂತೀರಾ?
Sir, inverse. Sir.
ಇನ್ವರ್ಸ್ ಐತಿ. ಒಟ್ಟಿಗೆ ಏನು ತಿಂತೀರಾ? ಅನ್ನ ತಿಂತೀವಿ ರೀ ಸರ ಅಂತ ಹೇಳ್ಬೇಕು. ಮುಂದಲ್ ಕ್ವಶನ್ ಕೇಳ್ತೀನ, ಅನ್ನ ಹೆಂಗೆ ಮಾಡ್ತೀರಾ? ಸರ್ ಕುಕ್ಕರ್ ಒಳಗೆ ಇಡ್ತೀವಿ ರೀ ಸರ. ದೆನ್ ಕುಕ್ಕರ್ ಯು ವಿಲ್ ಹೀಟ್, ದ ಇನ್ಸೈಡ್ ಏರ್ ಇಸ್ ದೇರ್, ಆ್ಯಸ್ ಯುವರ್ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸಸ್. ಹೆಂಗೆ ಇನ್ವರ್ಸ್ ಆಗ್ತದ? ಹೌದಾ? Temperature increases, pressure increases. Now we'll go to the properties now. Properties of fluid. The first one is mass. What is mass? Mass is accumulation of particles. Mass density. Mass density. Do you know gram means what? Gram. Gram means it is actually Sanskrit word it is. ಕೂಡು ಅಂತ ಅರ್ಥ. ಕೂಡು. ಗುಂಪು ಅಂತಾರಲ್ಲ ಗೊತ್ತಾ? ಗ್ರೂಪ್ ಗ್ಯಾದರ್ ಕೂಡು ಅಂತ ಗ್ರಾಮ್. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ? ಗ್ರಾಮ. ಯಾವುದಿದು ಗ್ರಾಮ? ಪಿರ್ನವಾಡಿ ಈಸ್ ಅ ಗ್ರಾಮ. ಗ್ರಾಮ ಪಂಚಾಯತ್. This gram means what? This is gram. That gram only we are using it here. Gram. Kg is measured in terms of gram. Kilogram. Megagram. Centigram. That is your gram. Density means what? Mass by volume. Means how many particles are there in a particular volume. How much mass is there in a particular volume. That is your density. Density is your kg per meter cube. Or gram per centimeter cube. But we will use this one. Kg per meter cube. Okay. Instagram. ಬೇಡ. ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ಅಂತಂದ್ರೆ ಏನು ಹೇಳ? ಇನ್ಸ್ಟಾ ಮೀನ್ಸ್ ವಾಟ್? ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ವರ್ಡಿಂದ ತೊಗೊಂಡ್ರ ಕಾಪಿ ಮಾಡ್ಯಾರ ಅವ್ರು. ಇನ್ಸ್ಟಾ ಗ್ರಾಮ್ ಮೀನ್ಸ್ ವಾಟ್? ಕಲೆಕ್ಷನ್. Instantaneously whatever that is there in your mind you put it. Make a gram. Make a group. Instagram. Next. Now tell me the relation between the temperature and mass density. Temperature and mass density. As the temperature increases, density increases or decreases?
Sir, decreases.
Decreases. Yes. Temperature increases, particle will move away from each other, then in a particular volume the density decreases. Therefore temperature is inversely proportional to this one. Now tell me, pressure and mass density, directly proportional or inversely proportional?
Direct, sir. Direct, sir.
Direct. Yes. As your pressure increases, mass density increases. Okay. Now one exception is there. Write down. Note. For water. Okay. For water, as the temperature increases, density increases. Correct tappa? Actually it is wrong, but this is valid from 0 to 4 degree centigrade. From 0 to 4 degree centigrade. Then later if you increase the temperature, density decreases from 4 to then degree centigrade, 4 onwards. Very important. Therefore, this 4 degrees centigrade is the point for water. This is called as a triple point. Triple point of water. Triple point of water. Boiling point, melting point, like that. This is called a freezing point, 0. Like that, it is called as a triple point. Right? This is all about mass density. Now, what is the mass density for air? Anyone remember? Density of air. Write down 1.2 kg per meter cube. Density of water 1000 kg per meter cube. Density of mercury 13,600 kg per meter cube. You should remember them. Density of wood 600 kg per meter cube. Some examples. Okay, you write one equation for your theory purpose. Rho is equal to P by RT. Very important equation. Okay, what is here? P is a pressure, R is a R ಏನಂತಾರೆ ನೋಡೋದನ್ನ ನೆನಪಿಲ್ಲ. R, I am not getting that name for that. T is a temperature.
ಸರ್ ಅದು ಐಡಿಯಲ್ ಗ್ಯಾಸ್
ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅದು ಯಾವ ಪ್ರಾಪರ್ಟಿ ಅಂತಾರ ನೋಡ್ಬೇಕು ಅದನ್ನ. Leave it, we'll see in the internet, we will see later. Now we'll go to the second property, that is a specific weight. Specific weight. Specific weight is your gamma, that is your equal to weight by volume. ನಮ್ಮ ಉಪೇಂದ್ರನ್ ಸ್ಟೈಲ್ ಒಳಗೆ ಹೇಳ್ಬೇಕು, ಗಾಮ ಗಾಮ ಗಾ ಅಂತಾರಲ್ಲ ಹಂಗೆ. ದಿಸ್ ಇಸ್ ಅ ಗಾಮ. ಏನು ಮಗ, ಏನು ಗಾಮ? What is unit? Newton per meter cube, you will remember. In soil mechanics we used to remember what? Kilonewton per meter cube, no? But here we will remember Newton per meter cube. Okay, then this unit weight is equal to rho into g. Rho into g. Rho you already know. G means what? Acceleration due to gravity. Acceleration due to gravity is 9.81. 9.81. 9.81 is actually average acceleration due to gravity. But acceleration due to gravity on the earth, it may vary from point to point. It may vary. That's why on the poles, these are the poles of earth. This is your longitudinal, latitudinal. This is a pole. G at pole you may have 9.83. 9.83. And G at equator you may have 9.78. 9.78. But for calculation purpose you consider 9.81. What is the unit? Meter per second square. Meter per second square. Next one, specific gravity is over. Next comes specific volume. Specific volume. Specific volume is denoted as a Vs, and this is a inverse of mass density. Inverse of mass density. See, this specific volume term most often we will use it for air or fluid gases measurement. Fluid ಒಳಗಡೆ air or gas measurement we will use specific volume, and we have a specific weight, no, specific weight. This one we will use, that is a rho, gamma, that we will use it for liquids. That is the difference between that and this. Specific volume 1 by rho, ಬರ್ಕೊಳ್ರೋ ಬರ್ಕೊಂಡ್ರೇನ್ರೋ. Next, specific gravity. Specific gravity. Specific gravity is a comparison of two densities. Comparison of two densities. Your substance density or substance unit weight or density you are comparing with some standard density or standard. Then this is your specific gravity. Usually in fluid mechanics they will use the word S, but we will use it G only. I will use G only because in geotechnical we have a practice of using G. Therefore G is equal to gamma divided by gamma W. Okay na? Gamma divided by gamma W. Gamma W is what? That standard fluid I am assuming it as a water. My standard fluid I am assuming it as a water, therefore gamma by gamma W. Or you can call it as a rho by rho W. Now we'll make a list. Water specific gravity 1, petrol specific gravity around 0.7, wood 0.6, next kerosene 0.8 or 8187, bitumen 1.02 or 0.5, concrete 2.4, concrete beda, cement 3.15, soil 2.6 to 2.7 or 7.8, steel 7.85, mercury 13.6. Can you tell me the material which has more than the specific gravity of more than the mercury? ಯಾರಿಗಾರ ಏನಾರ ನೆನಪೈತಿ? Any material which has a specific gravity more than the mercury? ನೆನಪಿಟ್ಟಿಲ್ಲ? $19.32. ಇದಕ್ಕಿಂತನೂ ಜಾಸ್ತಿ ಅದಾವ. ಪ್ಲಾಟಿನಮ್, these are all very heavy metals, but mercury is a shane because it is a flowable. It is a metal, but it is a liquid form. In liquid form mercury is the highest. In solid form we have many, right? Next, viscosity, very important. Now we are entering into the core part of the chapter. Viscosity, barcode, write down viscosity. The property by virtue of which offers resistance to the motion of one layer to other. Okay, simple definition, my definition. ಏನದು? The resistance offered by the two liquid layers or two fluid layers. The resistance offered between two fluid layers is called as viscosity. Right? Next, temperature. What is the difference between this temperature and viscosity? Viscosity and temperature, what you say? Directly proportional or inversely proportional?
Inversely, sir.
Here we have to be very careful that for liquids it is different, for gases it is different. Okay, for liquids, temperature, as your temperature increases, viscosity decreases. Viscosity decreases. Okay, for gases, as the temperature increases, viscosity increases. Best example for liquid is your ghee, tuppa. Ghee. In cold it will be very viscous, like a solid, and as you increase the temperature it loses its viscosity. Right? Next, you just in one corner you write this equation. In future it may be useful, but in civil engineering we don't use this one much. Mu is equal to d into e to the power of b by t. B by t. It is called as Andrade equation. Andrade's equation. What Andrade's equation tells is your temperature and E is, this is exponential appa matte udugara White's ratio alladu. E is not White's ratio, that is exponential power, e to the power anta. Then here write down D and B are Andrade's constant. D and B are Andrade's constant and T is a temperature. Absolute temperature, ABS temperature. Okay, and put a flower bracket. This is for liquids. Then we have a gases. We have a equation that is the mu is equal to alpha T 1 by 2 divided by 1 plus B by T. This is called as Sutherland equation. Sutherland antara. You can call Sutherland equation, where A and B are constants, T is the temperature. Where A and B are constants, T is the temperature. This equation is for gases. Have any doubts? Come to the discussion. If you have anything, you can ask.
ಸರ್ ಇದು ಪ್ರೆಷರ್ ಒಳಗೆ ಗೇಜ್ ಪ್ರೆಷರ್ ಒಂದು
The next chapter ಒಳಗೆ ಹೇಳ್ತೀನಿ. Gauge pressure, vacuum pressure, absolute pressure, atmospheric pressure. Next chapter I will explain that. Any other doubts here? Okay, we have two types of viscosities. One is a dynamic viscosity and the second one is a kinetic viscosity. Okay, dynamic viscosity is called as a mu. Kinematic viscosity is called as a nu. Dynamic, kinematic. Right? Now kinetic viscosity, that I will explain, but you just remember what is this kinetic viscosity and dynamic viscosity. dynamic viscosity and kinematic viscosity is, dynamic means what? Where first you should know the basic statics and dynamics. We have two branches, right? Statics and dynamics. This dynamics has a two branch. One is the kinetics and kinematic. Kinematic. Okay. Kinematic means where the force responsible for the motion is not studied. Force causing the motion is ignored. That is your kinematics. Kinetics means the force causing the motion is considered. Okay, best example is one person is crying here. This person is what? Crying. Why is crying? Crying means that is your viscosity. If you consider the person reason who made him to cry, then that viscosity is called as kinematic. If you ignore the person, reason ಇಲ್ಲ ನೀವು ಸುಮ್ಮ ಅತ್ಕೊಂತ ಕುಂತಾನ, why he is crying? He is ignoring the reason behind the cry. Kinematic. How to remember these two now, which are very confusing. Do you know kinetic Honda? Kinetic Honda, you know. Here you need to apply kick, no? When you apply kick, then only it moves. Kinetic. Force is required. Force is studied, considered for the study. You can remember like that. The dynamic viscosity means here you are studying the rubbing action between the resistance between the resistance between the two layers, and along with that you are considering the force causing the motion, that is your dynamic viscosity. But you are ignoring the force causing the motion, that is your kinematic viscosity. Okay. Now we'll go to Newton's law of viscosity. Very important. Now gate entry ಬಿಡ್ತಾ ಇದೀವಿ. Till now I can say that whatever I discussed, it is basic. Now we are entering for gate. Slowly gate is opening. Newton's law of viscosity. This is your Newton's law of viscosity. Shear stress is directly proportional to du by dy over. More specific, tau is equal to mu into du by dy. More specific, tau ಬೇಡ ಈಗ, f divided by area. Okay, f divided by area equal to mu into du by dy. Less specific, shear stress is directly proportional to shear strain. Shear strain. The question here is, I said shear strain, but in place of shear strain, why I wrote du by dy? This is a rate of change of velocity with depth. Rate of change of velocity with depth. Why? Because see, this is a water and this is the fluid is moving like this, and as you go deeper the velocity is changing. That's why the velocity profile I will draw it like this. See, the bottom layer is moving with this velocity, then this layer is moving with this velocity, this layer this velocity, this layer this velocity. See, as you go deeper and deeper at a distance y, then your velocity is changing, no? Your velocity is changing, right? Therefore we will consider it as a rate of change of velocity with respect to depth. That is nothing but shear strain. That is your shear stress is directly proportional to shear strain. This du by dy we can call it as velocity gradient. Velocity gradient. See here, there is some inclination. This velocity profile, there is some inclination is there. This inclination is called as velocity gradient. Now look at here. If this is a velocity profile and this is a y, and what is this? This is the velocity. du, right? Then what is this? Opposite by adjacent. This is a gradient angle. Opposite by adjacent. Du by dy. Understood? Now we need to study a lot in this equation. Here you should understand each and every term here. Shear force divided by area is equal to mu into du by dy. Okay. What is the shear force? What is this area? What is this du? Du I will write it here, velocity. Velocity. What is this dy? I will call it the thickness. Thickness. Let us consider one example. I have one table here. Okay, now this is one table, and here I will put one plate, solid plate I am going to put here. This is one solid plate, and here I will put some lubricant. This is some lubricant I will keep it here. Some lubricant I kept. Now what I do, I will take one rope and I will tie this rope. Tie this rope and take one frictionless pulley, and along with that it is coming, and here you apply some force F. Okay, you are here applying some force F means what? Here also you are applying some force F. Because of this force, what happens? This solid will move. It is moving with velocity u or du. The plate is moving with velocity du and force is applied F, and the thickness is there, no? Here lubricant thickness is there, no? That thickness I will consider dy over. Very easy, right? Then if you know the area of the plate, see this is your plate. Okay, if you know the area of the plate, whatever it is, here I considered a rectangular area. You can consider trapezoidal or circular, semicircular, whatever that plate area. If you know the plate area, that is your area. Then how much force you are applying here in this direction means shear force. That is your shear force. Then at what velocity, because of all these arrangement, at what velocity the body is moving? Velocity. Then how much thickness you are using your lubrication below that one? Because of that it is moving, no? Therefore that is your thickness of the lubrication. Then if you know all of them, then you can calculate dynamic viscosity of the fluid used, dynamic viscosity of the lubricant used. Any doubts? Then now tell me, what is the unit of dynamic viscosity? Dynamic viscosity is equal to tau divided by du by dy. Tau is Newton per meter square. This is meter per second, and this is 1 by meter. Meter cancel. Therefore, Newton second per meter square is a dynamic viscosity unit. Dynamic viscosity is Newton second per meter square, or you can call it as a Pascal second. See how easy it is. This is your Pascal second. Interesting, right? Now we will study what are the twists they make for shear force. What are the twists they make for area? What are the twists they make for mu? What are the twists they make for velocity? What are the twists they make for distance? If you know all of them, then I can say that in this chapter 1 marks is a fix, you can earn, okay, without any doubts. Now this shear force is there. Now in the previous diagram I shown you that one force is there, frictionless pulley is there, and this is the force which is causing the flow, which is the responsible to move this body, that I got it. But sometimes what happens, look at here, if your surface is like this, if this is your surface and you put one plate here like this, then you are putting lubricant in between here, then you are pulling it like this. Yes, of course. Now here also F is same only, that whatever it is there here. But this force sometimes it is not pulling like this. If it is pulling like this, then you need to take along the direction of the plate movement. Therefore, you write what is shear force. Shear force is what? Force along the direction of motion. Force along the direction of motion. Force along the direction of motion. Area of the plate with which a lubricant is contact. Okay, area of lubricant athwa the plate, the contact area between the plate and lubricant. Contact area between plate and lubricant. Plate and lubricant. du is a linear velocity. Linear velocity du. Now look at here. I will study about here, I will explain you about here how to take F. See, if the plate is like this, you are pulling it like this, then F is okay, done. If the plate is like this, you are pulling it like this, then done. If the plate is like this, but if you are pulling it like this, then you should know the angle, convert or resolve this force into this direction and take this as a F, done. Okay, if the plate is like this and someone is pulling like this and someone is pulling here also, then take, say this is a 10 kilonewton, this is a 5 kilonewton, then you need to take F equal to 5. 10 minus 5, no, we will take 3 here, then 10 minus 3, 7 kilonewton you need to take and go ahead. If the plate is like this and this is pulled like this and self weight of the plate is something like this, okay, W, then what you need to do? This is F, already you know. Then this W will contribute in this direction, W. Then what is this theta? If it is theta, then this is the W cos theta. Then what is the force causing the motion? Force causing the motion, I don't know whether W cos theta is more or F is more. If W cos theta is more, then it will move in this direction. If F is more, it will move in this direction. Then that you need to take, that is your force causing the flow. Getting the point? Okay. Sometimes it happens like this also. Not only these linear plates. Sometimes, see, there is a one tank like this. There is one space like this, and you are going to put your plate in between. Let us consider one plate is kept here inside. And with the help of rope you are going to pull it out. This is your plate. It look like this. This is your plate. You are pulling it out. Then here some liquid is there here. Then there is a friction, no? There is a this lubricant and that plate, they are in contact. This is also one problem. Sometimes it may happen like this. Two rigid surfaces are there like this, and two rigid surfaces are there like this, and one plate which is moving inside. One plate which is moving inside. Shrink. But here there is a liquid here. Then again you can use that equation. You have to use that equation. Now I explained you linear motion of plates. Plates are moving in one direction. Sometimes look at here. This is your sleeve. Sleeve andre ಏನು? Sleeve means what? Sleeve means this is a sleeve. Sleeve andre ಏನು? ತೋಳು ಅಂತಾರೆ, ತೋಳು. Then this is your sleeve. Inside the sleeve we are going to put what? A shaft. That's why we will call it as a sleeveless. It's half sleeve, half sleeve shirt. Then we are putting what? Shaft. Inside we kept one shaft. Now this shaft is rotating. That shaft is rotating. Now you have, this is rotating now here, but it has a casing. ನಿಮಗೆ ಅದು ಸ್ಲೀವ್ ಅರ್ಥ ಆಗಲಿಲ್ಲ, you think that it is a casing. It has a casing like this, and here you are putting lubricant. Where? Here you put lubricant. So many times you have seen in that what in wheat floor, hittin ಗಿರಣಿಗೆ ಹೋಗಿರ್ತೀರಲ್ಲ, there you will see that one shaft will be there like this, and this is will be rotating. This will be rotating, and here some lubricant will be kept. This is also one problem they can ask in exam. Okay, sometimes they may ask you questions like this. Say one cone shape, this what one table or something is there, arrangement is there, then here you will put one circular cone like this, prism, circular prism like this, then you will rotate this one continuously. Then here you put a lubricant. See, this is also problem they can ask. Many problems they can create and ask. Even sometimes they may ask you like this, that what a plate on ocean, oceans will be there, no tides are big, tides are there, then one person who is standing like this and who will be moving swinging there. Those problems also they can give. But it is all about what you should know. What is F here? What is F? F is a force in the direction of flow. Then what is area? Area is, that is very simple, that if it is a rectangle, you know the area, circular, triangular, trapezoidal, or otherwise any area, you know that one. I don't worry about that area. Now velocity, linear velocity, you know, see, linear velocity, you know, nothing to worry about. For this diagram, it is moving in this direction, u, 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 moving in this direction, u. See, for all the problems, this moving in this direction upward, u, moving in this direction upward, u, in this direction, u. Coming to this problem, we are not observing any linear velocities, we are observing angular velocity. Very interesting, right? We are observing angular velocity. Angular velocity means this is a shaft like this, and this shaft is rotated like this. When it is rotating at a particular axis. About that axis only it is rotating, it is not moving in a linear direction. Therefore, this rotation will be always given as RPM, revolution per minute. Revolution per minute. Then revolution per second we will make it by dividing 60. Then what it becomes? 1 revolution per second, because minute by 60. Then 1 revolution means what? Okay, this is one cylinder like this. 1 revolution means what? 1 revolution means this is 1 circumference. It will move in 1 circumference. Therefore, circumference is what? Pi d. Therefore, pi dn divided by 60. This is I can use it a formula, conversion formula. Now, what is n? N is the angular velocity, and angular velocity you are going to convert it into what? Linear velocity. Angular velocity converting into linear velocity. Now in this entire equation, what you have? Pi is a unitless, and diameter is a meter. Revolution per minute, minute and this 60 gone. Revolutions, that will be n will be taking care of that. Therefore, you got it in meter per second. Means you remember that u is equal to directly velocity, it is a distance by time, or u is equal to pi dn by 60, where n is in rpm and the unit is in meter per second. Any doubts? Do you have any doubts here? No doubt. This is over, this is over, this is over. Now think about why. Think about why. What is this why? Why is the thickness of lubricant? Very easy. Here in this case, this is your lubricant thickness. This is the thickness of the lubricant. When you come to this diagram, this side lubricant is there, this side lubricant is there. Here also this side and this side lubricant. Top and bottom lubricant. Side by side lubricant. In this one, this is the lubricant. That thickness you are going to measure it. That is your dy. That is your dy. Now if you know all of them, then you will calculate the equation, you will substitute and you will get the equation. Tau is equal to mu into du by dy. Now a twist for mu. Twist for mu. Mu, if it is directly given as a Pascal second, feel happy. If it is given as a Newton second per meter square, feel happy. But if mu is given in terms of poise, if a mu is given in terms of poise, then you need to convert. Like 10 poise is nothing but 1 Pascal second. 1 Pascal seconds is equal to 10 poise. Understood? This relation you need to use and convert your dynamic viscosity into your required unit, that is your Pascal seconds. Okay, now I am going to open it for discussion. If you do want to ask anything, any particular concept not understood. No doubt?
Sir, first slide ತೋರಿಸ್ರಿ
ಒಂದು ನಿಮಿಷ ಇದೊಂದು ಬರೆದು ಬಿಡ್ತೀನಿ. 1 poise equal to 0.1 PA second or 10 poise equal to 1 PA second. First slide ಬೇಕಾ? Go to first.
ನ್ಯೂಟನ್ಸ್ ಲಾ ಬರ್ತಿದ್ರಲ್ಲ ಸರ್,
ಸ್ಲೋ ಆಗಿ ಹೋಗ್ಲಿ.
ಅಲ್ಲ ಸರ್, ನ್ಯೂಟನ್ಸ್ ಲಾ ಬರ್ತಿದ್ರಲ್ಲ ಸರ್,
ಆ ಸ್ಲೈಡ್ ಬರಲಿ.
ಪ್ರೀವಿಯಸ್
ಇದೆ. ಓವರ್. Okay, now we will cover a little bit theory. Types of fluid, very important. 1 marks ಕೇಳ್ಬಿಡ್ತಾರ. They will definitely confuse you and ask a question. Types of fluid. Types of fluid. ಹೇಳ್ರಿ
ಸರ್. ಸ್ಟೋಕ್ ವಿಸ್ಕಾಸಿಟಿದಾಗ ಬರ್ತದೆ.
ಸ್ಟೋಕ್ ಈಸ್ ಅ ಕೈನೆಟಿಕ್ ವಿಸ್ಕಸಿಟಿ. ಒನ್ ಮೋರ್ ಥಿಂಗ್, ಅದನ್ನ ಹೇಳಿ ಈ ಕಡೆ ಬರ್ತೀನಿ ಹಂಗಾರ. ಡಿಲೀಟ್. See here, dynamic viscosity, you got it. Dynamic viscosity is a Pascal second or Newton second per meter square. Kinematic viscosity is a definition is mu by rho. Right now, kinematic viscosity to the mass density. Now, what is the kinematic viscosity unit? Newton second per meter square, and this one is what? Kg per meter cube. Kg per meter cube. Then what is this Newton? 1 Newton equal to? Newton is mass into acceleration, no? Mass into acceleration is meter per second square. Means in the place of Newton I can write this one. Therefore it is kg meter per second square into second by meter square divided by kg per meter cube. Then kg cancel, meter square meter cancel, then 1 second cancel, then here 1 meter and here 1 meter, therefore it's a meter square, and this is 1 s, therefore yes, therefore your kinematic viscosity is equal to meter square per second. Dynamic viscosity is Newton second per meter square. Dynamic viscosity can be measured in poise. Kinematic viscosity will be measured in Stokes. Dynamic viscosity 1 poise is equal to 0.1 Newton second per meter square. But 1 Stoke is equal to 1 Newton, 1 centimeter square per second. Now how to remember this one? Stoke inside K is there, therefore this belongs to kinematic viscosity. Poise is written as like this, and this P is reversed, then it look like a D, therefore it is for dynamic viscosity. ತಿಳಿತಾ ನಿಂಗಣ್ಣ? ಮರಿಬಾರ್ದು ಈಗ. ಪಾಯ್ಸ್ ಅಂತಂದ್ರೆ ಡೈನಮಿಕ್, ಸ್ಟೋಕ್ ಅಂದ್ರೆ ಕೈನಮೆಟಿಕ್, ಬಿಕಾಸ್ ಸ್ಟೋಕ್ ದೊಳಗೆ ಕೆ ಅದ. Inside the stroke there is a K, therefore it is a kinematic. Shall we move ahead? Any doubts? Okay, next. See here, they will ask you one question and they will confuse you. Look at here. Tau is equal to mu into du by dy. Right? Now the question is the same problem I will consider, and there is a plate here and there is the force here and some liquid is there here. Okay, if the velocity of the plate is more increasing, then the dynamic viscosity what happens? If the velocity of the plate is increasing, then the dynamic viscosity will increase or decrease? Let's read. Neeru. Hi. What happens? Any comment?
Decreases, sir.
Bakra. Remains constant, because Anna Don told that du by dy is directly proportional, and we took it as a proportionality constant for this one. There is a increase or decrease that is there with respect to shear and shear strain. Increase and decrease, there is no comment on this mu. Therefore mu is remains constant. Mu is a property of that lubricant. ನೀ ಆ ಲುಬ್ರಿಕೆಂಟ್ನ ಎಲ್ಲಾರ ಹಚ್ಚು, ಪ್ಲೇಟ್ middle ಆದರೂ ಹಚ್ಚ್ರಿ, or you can apply it for a shaft, or you can apply it for wherever you want, but dynamic viscosity is same, constant it is. Right? ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಹುಷಾರಾಗಿರಿ. Now we'll go to the type of fluid. Then we have, in this universe we have only two types of fluids. The first one is a Newtonian fluid. Newtonian fluid, and the second one is the non-Newtonian fluid. Non-Newtonian fluid. Near Newtonian fluid means those fluids which obey Newton's law, and non-Newtonian fluids means those fluids which does not obey, which do not obey Newton's law. Newton's law already I told you. If it is obeying, okay, obey agಲಿಲ್ಲ ಅಂದ್ರೆ non-Newtonian. Right? Now write it here. Water is an example for Newtonian fluid. Water is an example for Newtonian fluid. There are many such fluids are there. Now coming to here non-Newtonian fluid, we have two types. The first one is a time independent and time dependent. Time independent and time dependent. Time dependent. For example, time independent is a dilatant. Dilatant. And the Bingham plastic. Singham alla. Bingham antar. Bingham plastic. And we have another one, pseudo plastic. ಸುಡ್ತಿರಂಗಿಲ್ಲ ಅದು pseudo plastic ಅಂದ್ರೆ means false plastic. Pseudo means what? False. Okay, therefore, and here thixotropy. Thixotropy, time dependent. No, see here, time dependent. Next, rheopatic. Rheopatic, RHE, rheopatic. See, you computation ಭಾಳ ಸತಿ ಕೇಳಿದಾರೆ. In GATE exams they have asked some these questions. Okay, now one by one. In general, see here, Newton ಬರೋಕ್ಕಿಂತ ಮುಂಚೆ, Newton has arrived, no? Before Newton, we have an equation that is the tau is equal to A into du by dy to the power n plus b. Okay, ಅಣ್ಣ ಡಾನ್ ಏನದನಲ್ಲ ನ್ಯೂಟನ್ ಡಾನ್, he made it very easy. Newton, he made it very easy. He took A is equal to 1, B is equal to 0, n is equal to 1. Jai Bajrangbali. If you substitute all of them here, what happens? Look at here. A is equal to du by dy. Sorry. A is equal to mu. A is equal to 1 alla. A is equal to mu, B is equal to 0, n is equal to 1. Then this is your equation. ಯಾರು ಬಂದ್ರಿ ಇಲ್ಲಿ? ನ್ಯೂಟೋನಿಯನ್ ಫ್ಲೂಯಿಡ್. ನ್ಯೂಟೋನಿಯನ್ ಫ್ಲೂಯಿಡ್ ಮೀನ್ಸ್ n is equal to 0, 1, B is equal to 0 and A is equal to mu. Okay, or you can write it like A and B are constants. And n is a power of gradient. Power of gradient ಅಂದ್ರೆ ಏನೀಗ? Look at here. ಸ್ವಲ್ಪ maths ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. You should know, you should apply each and everything into every subject. Y equal to mx plus c. Mx plus c. Look at here. C is a y-intercept. Yeah, this is a C. Yeah. M is a slope. Yeah. This is your y equal to mx plus c. Right? Here, if I make x square, then what happens? This become parabola. This become parabola. Then if I make it minus, then it may become, I don't know, but it may become like this. Or if I substitute some fractions, it may become like this. Then C becomes 0 means it may become like this, or it may become like this, or it may become like this. See, these are all the graphs. Like that. Like that, we will have equation. The Newtonian fluid means what? Newtonian fluid means what? B equal to 0. and n equal to 1, then obviously this is a representation of Newtonian fluid. ಬರ್ಕೊಂಬಿಡ್ರಿ ಇದ್ರ ಮೇಲೆ ಬರೀರಿ Newtonian fluid. That I will write it clearly. This diagram is very important. Make a big diagram for this. Straight line, Newtonian fluid. Newtonian fluid. One type is over. Second type, what all you can make now? Here I can make n is greater than 0, sorry, greater than 1, and b I will make it 0, mu let it be as a is a mu. Then what you can have here now? What equation you can have? Tau is equal to mu into du by dy, where n power n, this much you got. Okay, and this one, how you can represent here? N is greater than 1, therefore you have a dilatant, and this graph you are going to have a dilatant. Okay, this is your dilatant fluid. Dilatant. Right, best example for dilatant is butter or quicksand. ಇನ್ನೊಂದು ಎರಡು ಕೊಡ್ಲೇನು ಚಲೋ? ಆರ್ ಗೋಧಿ ಹುಗ್ಗಿ. ಗೋಧಿ ಹುಗ್ಗಿ, or it means what? When you shake it, no, then you will observe the fluid coming at the top. Okay, when you shake it, then there will be some disturbance in the fluid. Sumitra solid adu, sumitra gattirtaiತಿ. That is the best examples for these. And the third one is, what you can make now? Look at here, I will make n equal to 1 and b not equal to 0. I will make it b not equal to 0. B not equal to 0 means what? B is a y-intercept, means here I will get, and n equal to 1, straight line. N equal to 1 means what? Linear, straight line. This curve I got, that I will represent here somewhere, straight line. This is your B, n equal to 1. This is called as Bingham plastic. This is called as Bingham plastic. Bingham plastic. Bingham plastic best example is your sewage sludge. Sewage sludge. Your toothpaste. Toothpaste is there, no? Toothpaste or gel, any gel. Any gel. Right? Next we will have, third one is over. The fourth one we will have, the fourth one we have, we will make it like that n we will make it less than 1 and b we will make it 0. Now see, what is that? B is 0 means starts from here. N is less than 1 means like this. Pseudoplastic. Plastic alla, pseudoplastic. Pseudoplastic means false plastic, behaves like a plastic but it is not plastic. Okay, yavadu example? Pooja, example Priyadarshini, Rajeshwari, next Sushmita. You have to tell the example. Behaves like a plastic but it's not a plastic. Pseudo. No.
Glass.
ಯಾರು ಹೇಳಿದ್ರೆ ನಿಂಗಣ್ಣ? ನೀನು ಕೇಳಿಲ್ಲ ನಾ ಯಾರನ್ನ ಕೇಳಿ ನೋಡು. ಪೂಜಾ, ಪ್ರಿಯದರ್ಶಿನಿ, ರಾಜೇಶ್ವರಿ, ಇವ್ರು ಮೂವರು ಹೇಳ್ಬೇಕು. ರೈಟ್ ಡೌನ್. ಲಿಪ್ಸ್ಟಿಕ್. Lipstick is a fluid, okay, or paint, ಈಗ ನಿಂಗಣ್ಣ ಹೇಳ್ಬೋದು ನೀ ಏನಂತ, ಬ್ಲಡ್ಲೆ ಯಾರಿಗಾರ ಲೆಟರ್ ಬರ್ತಿದ್ದಿ ಅಂದರೆ ದಟ್ ಈಸ್ ಅ ಸುಳ್ಳು ಅಂತದು, ಸುಡೋ ಪ್ಲಾಸ್ಟಿಕ್. ಐ ರೋಟ್ ಅ ಲೆಟರ್ ಬೈ ಯೂಸಿಂಗ್ ಸುಡೋ ಪ್ಲಾಸ್ಟಿಕ್ ಅಂತ ಹೇಳ್ಬೇಕು ಫಸ್ಟಿಗೆ. ಐ ರೋಟ್ ಯು ಅ ಲೆಟರ್, ಲವ್ ಲೆಟರ್, ಬೈ ಯೂಸಿಂಗ್ ಅ ಸುಡೋ ಪ್ಲಾಸ್ಟಿಕ್ ಲಿಕ್ವಿಡ್ ಇರಬೇಕು. ಓಕೆ. ಇಫ್ ಶಿ ಕೂರ್ಲಿ ಅಂದ್ರೆ ಚಲೋತ್ತಾಗಿ ನೀನು ರೆಸ್ಪಾನ್ಸ್ ಮಾಡಿ, ಇಫ್ ಶಿ ಟೋಲ್ಡ್ ದಟ್ ಯಸ್ ಮೈ ಡಿಯರ್ ವೆಲ್ಕಮ್ ಅಂತಂದ್ರೆ ಸುಡೋ ಪ್ಲಾಸ್ಟಿಕ್ ಮೀನ್ಸ್ ಬ್ಲಡ್ ಅಂತ ಹೇಳ್ಬೇಕು. ಇಫ್ ಶಿ ರಿಜೆಕ್ಟ್ ಯು ದೆನ್ ಯು ನೀಡ್ ಟು ಟೆಲ್ ದಟ್ ಸುಡೋ ಪ್ಲಾಸ್ಟಿಕ್ ಮೀನ್ಸ್ ದಿಸ್ ಇಸ್ ಅ ಫಾಲ್ಸ್ ಪ್ಲಾಸ್ಟಿಕ್, ಫಾಲ್ಸ್ ಕಂಟೆಂಟ್, ಇಟ್ ಇಸ್ ನೆಗೆಟಿವ್ ಫೀಡ್ಬ್ಯಾಕ್. ರೈಟಾ? ರೈಟ್. ಪಾಲಿಮರಿಕ್ ಸೊಲ್ಯೂಷನ್ is an example. Polymeric solution, blood, polymeric solution, paint, lipstick, these are all example for pseudoplastic. Then we have a fifth one. In this fifth one I will make it n less than 1 but b not equal to 0. How you may get a graph? b not equal to 0 here, n less than 1 concave, yeah, thixotropy. ಹಾಂ, ಥಿಕ್ಸೋಟ್ರೋಪಿ ಹೇಳ್ರಿ, ಯಾರು ಹೇಳ್ತೀರಿ? ಮತ್ತೆ ಅವ್ರು ಮೂವರೇ ಹೇಳಿ ಈಗ, ಪೂಜಾ, ಪ್ರಿಯದರ್ಶಿನಿ ಆ್ಯಂಡ್ ರಾಜೇಶ್ವರಿ.
Sir, thixotropy and renomate.
Thixotropy means it is a viscosity increases with time. ಅಂದ್ರೆ ಟೈಮ್ ಆದಂಗೆಲ್ಲ ಅದು ಗಟ್ಟಿ ಆಗಿಬಿಡ್ತೈತಿ. Viscosity increases. First it is somewhat like a liquid and later it becomes solid type.
Nail polish.
ವೆರಿ ಗುಡ್. ನಾ ಹಿಂಗೆ ಮಾಡವಿದ್ದೆ ನೀವು ಹೇಳ್ಬಿಟ್ರಿ. ನೇಲ್ ಪೇಂಟ್, ಓಕೆ, ಆರ್ ಪ್ರಿಂಟರ್ಸ್ ಇಂಕ್. Printer's ink is what, how it will be? Your whitener is a liquid, no, inside, and after applying that, after some times it becomes solid, right? That is your thixotropy. Nail paint or whitener, examples. Enamel anತಾರೆ, enamel or printer's ink. ಪ್ರಿಂಟರ್ ಇಂಕ್ ಪೇಪರ್ ಮೇಲೆ ಚೆಲ್ತಂದ್ರೆ ಏನಕ್ಕೈತೆ, ಗಟ್ಟಿ ಆಗಿಬಿಡ್ತದೆ ಆಮೇಲೆ. ಬಟ್ ಬ್ಲಡ್ ಈಸ್ ಆಲ್ಸೋ ಆ್ಯಕ್ಟ್ಸ್ ಲೈಕ್ ದ್ಯಾಟ್, ಬಟ್ ಬ್ಲಡ್ ವೋಂಟ್ ಕಮ್ ಹಿಯರ್. ಬ್ಲಡ್ ಆ್ಯಕ್ಟ್ ಲೈಕ್ ಅ ಥಿಕ್ಸೋಟ್ರೋಪಿ, ಬಟ್ ಡೋಂಟ್ ಕನ್ಫ್ಯೂಸ್ ವಿತ್ ದ ಬ್ಲಡ್ ಆ್ಯಂಡ್ ಥಿಕ್ಸೋಟ್ರೋಪಿಕ್. ನೆಕ್ಸ್ಟ್, last one we have one more option. What is left here? Look at here in this graph, what is left? One more graph I can draw, no? This one. What is that? B is not equal to 0 but n is greater than 1. Sixth one, B is not equal to 0, n is greater than 1. Rheopatic fluid ಅಂತ. Viscosity decreases with time. ಬರ್ಕೊಡ್ರಿ, viscosity decreases with time. Example, viscosity decreases with time. You may not know. Write down gypsum solution in water. Gypsum solution in water or bentonite